All right, fifth graders. So we're getting into our next lesson here for today. What place should you use when comparing the numbers? Which place should you use when comparing the numbers? We're going to be talking about comparing decimal numbers today. And so we're going to first start this first set of numbers. We have 0 and 87 hundredths, 0 and 89 hundredths. Now notice they're not asking us to tell which one is bigger or smaller. They're simply asking us which place that we should use when comparing the numbers. So whenever I'm comparing numbers, I always start way to the left. And in this situation, I see that they're both zeros, so that doesn't help me. I go to the next place, which is the tenths place. I see that we have an 8 here and an 8 here. That doesn't help me. They're the same. So I go to the next place. So this was the tenths, then the hundredths. I see that this is a 7. I see that that is a 9. And so that's where they become different. So the place that I should use in this one would be the hundredths. Now, my next two numbers, 19 and 273 thousandths, 19 and 567 thousandths. So I see that the ones in the tens place are the same. I see that the nines in the ones place are the same. And here after the decimal, the tenths place, that's the first one where they're different. So the number that I should use when comparing them would be the tenths place. Last one in this section, 8 and 72 hundredths, 8 and 729 thousandths. I see that the 8s are the same in the ones place. After the decimal, I see that the 7s are the same in the tenths place. I see that the 2s are the same in the hundredths place. And in this number, I have a number in the thousands place, but I have no number here. So the place that I want to look at would actually be the thousands place, because that is where they begin to be different. All right. So now we're looking at comparing. So we're going to go through that process of actually comparing. And when I compare, I'm going to use the greater than sign. I'm going to use the less than sign. And I may even need to use the equal to sign or the equal sign. You've probably heard this before, but if you were imagine that this was like playing a Pac-Man game or with some sort of animal, the mouth is always open to the bigger number. Sometimes some people get confused and think, well, we're going to point to the bigger number. No, it's actually going to point to the smaller number. Imagine this is a mouth. If the one on the left is bigger, we're going to use this one to show that this number is bigger. If the one on the right is bigger, we're going to use this one to show that the number over here is bigger. So I start with what's way to the left. The ones place here, I have a 5. The ones place here, I have a 5. They're the same. Here in the tenths place, I have a 6. Here in the tenths place, I have a 2. So it doesn't matter what comes after, because a lot of people are going to say, well, this is 287. This is 67. So this has to be bigger. Well, actually in decimals, if there's 1, 2, 3 digits after the decimal here, and I only have 2 digits after the decimal here, I'm actually allowed to go ahead and add a 0. Now, you don't have to do this on your paper. I'm just kind of showing you this extra. We'll talk about this in class 2. So that allows you to help you compare so you can have the same amount of digits after the decimal in both numbers. And once I do that, that 0 has no value. I didn't add anything. It just now looks like it's 670. And this is just 287, which we know 670 is bigger than 287. But really, the real reason why this number is bigger is because the 6 in the tenths place is bigger than the 2 in the tenths place. I could keep adding numbers here all day long. I won't do that because it's not that fun. But the fact that the 6 is bigger than the 2 makes this the bigger number. All right, so here we go. 4 and 6 hundredths, 4 and 60 thousandths. Well, 4 in the ones place, 4 in the ones place. 0 in the tenths place, 0 in the tenths place. 6 in the hundredths place, 6 in the hundredths place. Now here I have a 0 in the thousandths place, and here I have nothing in the thousandths place. So that can be confusing. Well, remember what we said on this one. Since I have 3 numbers after the decimal here, I can make it so this one also has 3 by adding a 0 here after the 6. All right, and if you can't envision that, it's not bad to do that. Well, now all of a sudden, I have the same exact number, 4 and 60 thousandths, 4 and 60 thousandths, which means those two are equal. All right, now here, we're going to try to confuse you a little bit, but you do not need to be confused, where one of the numbers is going to be in word form. So if I think about this number, this is 3 and 891 thousandths. Tenths, hundredths, thousandths. 3 and 891 thousandths. This number is 3 and 895 thousandths. When we get one in word form, we're going to want to go and put that in standard form. So this is 3 and, so I know it's going to be 3, then a decimal for 3 and then 895 thousandths. So I think about 895 and what that looks like. I know that looks something like that, 895. That 5 is going to be in the thousandths place. Now when I think about my decimal place values, remember, first comes tenths, then hundredths, then thousandths. So that 5 has to be in the third place, tenths, hundredths, thousandths, which means that this is going to just go as 3.895. And my 8 is going to go in the tenths place, my 9 is going to go in the hundredths place, my 5 is going to go in the thousandths place, 3 and 895 thousandths. But then I need to compare them. Well, I see that the 3 in the ones place is the same. The 8s, I have an 8 in the tenths place in both numbers. I have a 9 in the hundredths place in both numbers. Here I have a 5 in the thousandths place. Here I have a 1 in the thousandths place. Okay, which tells me that this number is going to be bigger. So I'm going to have my mouth open to that number. All right, so let's move right along. Ordering from least to greatest, kind of just a different way of doing the same thing. Ordering from least to greatest. Now, when you order from least to greatest, I didn't do a great job here, but sometimes it's good to rewrite the numbers all above each other, but line up the decimals. So if I were to do that, just as kind of a visual, almost a scratch work way of doing it, 3 and 74 hundredths, 0.3, and then 0 and 374 thousandths. All right, and so that allows you to get those decimals lined up like you were adding and subtracting. We'll be talking about that here in the not too distant future, to be able to compare them, least to greatest. So first of all, I'm going to say, well, okay, I see a 3 here, a 0 here, and a 0 here. That tells me already that that's the biggest number, 3 and 74 hundredths. So now I'm just down to these two. Well, here they both have zeros in the ones place. Here they both have 3s in the tenths place. But this one has a 7 in the hundredths place. This one has a 4 in the thousandths place. So clearly, because this has a 7 and this has a 4, okay, this number's bigger, which means that this is the smallest number in the set. So from least to greatest, it's going to be 0 and 3/10, followed by 0 and 374 thousandths, followed by 3 and 74 hundredths. Looking at this one, ordering from least to greatest, I did a much better job lining the decimals up. So, but this one gets a little more confusing because I see that they all have a 2 in the tens place. They all have an 8 in the ones place. These two have zeros in the tens place, and this has a 2. The fact that this has a 2 in the tens place and all these are the same tells me that's the greatest one. So I'm going to ignore that one till the end. Now I'm trying to figure out which one is least between 28 and 200ths or 28 and 2,000ths. Well, we know the 2 in the tens place are the same. We know the 8s in the ones place are the same. They both have zeros in the tenths place. This one has a 2 in the hundredths place. This one has a 0. This 2 makes no difference. The fact that this has a 2 in the hundredths place and this one has a 0 makes this the bigger number, which means that if I put them in order from least to greatest, first comes 28 and 2,000ths, followed by 28 and 200ths, followed by 28 and 2/10. That would be putting numbers in order from least to greatest. All right, the last part says complete the number to make the statement true, which means that I'm basically needing to put a number in here to make the entire statement true. This says 36 and 7/100ths is equal to 36.0 and something needs to go in there. Well, that's going to be pretty obvious because it says they need to be equal. The 3, they both have 3s in the tens place. They both have 6s in the ones place. They both have 0s in the tenths place. This has a 7 in the hundredths place, which means if the number is equal, this one also needs to have a 7 in the hundredths place. Anything else there would make these two numbers not equal. So it would have to be a 7. 4 and 278,000ths is less than 4 and 2 something with an 8. So let's think about our places. Ones place, they both have 4s. Tenths place, they both have 2s. Now this has a 7 in the hundredths place, and that's where we have our blank spot here. This has an 8 in the thousandths place. This number also has an 8 in the thousandths place. This number needs to be bigger because that's where the mouth is opening to. Well, I think if I put a 7 here, then they're the same number. So I can't put a 7 here because this number has to be greater. So I can really put anything here that's bigger than 7. I could put an 8 here, and it would be good. It would be correct because 4.4 and 288 thousandths is bigger than 4 and 278 thousandths. I could put a 9 here because 4 and 298 thousandths is bigger than 4 and 278 thousandths. I don't need to put both, okay, but you do need to put a number there, only one. Only need to fill in one number that would make the statement true, and either putting an 8 there or a 9 there would work. All right, last one. 5 and 76/100ths is greater than 5 and something with a 4 in the hundredths place. So when I'm comparing them, I see that they both have a 5 in the ones place. This has a 7 in the tenths place. That's where our blank spot is, the tenths place. This has a 6 in the hundredths place. This has a 4 in the hundredths place. Well, so let's think. This number has to be the bigger number. So let's think what would happen. So clearly, if this number has to be bigger, I can't put something less than 7 in here because this would be 5.7. So this has to be a minimum of 5.7. If I put a 6, 5, 4, anything less, it wouldn't work. So let's just see if 7 would work. That would give me 5 and 74/100ths. This is 5 and 76/100ths. The 6 is bigger than the 4. So this can't be a 7. 7's not going to work. All right, but let's try it with an 8. If I put an 8 there, the 8 then in the tenths place is now bigger than the 7 in the tens place. Okay, well, I just realized I messed that up. My complete apologies for the last minute of my talking. 6th grade. I just realized I messed that up. Okay? Let me rewind on that. My apologies. And this is just a lesson that sometimes Mr. Swack makes a mistake. And I'm human just like everybody else, but I'm not going to totally redo the video just for that. This number is greater. Okay? So I need to go back on what I said. With this being a 7 in the tens place, okay, the biggest this could be is a 7. Because if I put an 8 here, or I put a 9 here, it's going to be too big. Because the 8 and the 9 would be bigger than the 7, which means that it couldn't work. Now, if I actually go and put a 7 in here, okay, that actually would work, okay? Because 5 76 hundredths is greater than 5 74 hundredths because the 6 is bigger than the 4. That would make that true. But it would also be true if I put in anything less than a 7. 6, 5, 4, 3, 2, 1, or 0, okay? Because the 7 would be bigger than a 6, a 5, a 4, a 3, a 2, a 1, or a 0. My apologies to any 5th graders or 5th grade parents or anybody that was watching this video for my little fumble there on the last problem. But we got that all figured out. All right, have a great day. Talk to you later. Bye.